Newton's third law of motion states that for every action force, there is an equal and opposite reaction force. Rockets clearly show Newton's third law in action. When a rocket burns fuel, hot gases are forced out the bottom of the rocket at high speed. The fast-moving gas particles are pushed by the rocket chamber in one direction, and the gas particles, in turn, push the rocket in an opposite direction. This creates a net force that thrusts the rocket in the opposite direction of the ejected gases. In this lab, the rocket will be propelled by a gas released from a chemical reaction. Chemical reactions are all around us. Reactants are constantly being rearranged into new products. For many chemical reactions, clues to indicate that a reaction occurred can be observed. Such clues include production or absorption of heat, absorption or emission of light, production of a sound, a change of color, formation of a precipitate, or release of a gas. Some chemical reactions may exhibit only one of these clues, while other chemical reactions may reveal several clues. By looking for these clues, it can be determined whether a chemical reaction has occurred. Using sodium bicarbonate and acetic acid, a gas will be produced and the force will thrust the rocket in the opposite direction. In chemical reactions, mass is neither created nor destroyed. This is known as the law of conservation of mass. Any chemical change involves the reorganization of atoms into one or more new substances. In a chemical equation, the number of atoms on the left of the arrow must equal the number of atoms on the right of the arrow. Balanced chemical reactions are used for stoichiometry. Stoichiometry is the branch of chemistry that deals with the numerical relationships and mathematical proportions of reactants and products in chemical reactions. Using stoichiometry, the limiting and excess reactants can be determined. The limiting reactant is the reagent used up in the reaction and on which the overall yield of the product depends. The excess reactant is the reactant that is not completely used up during the reaction.